Okay, here goes video number 2. Let's start with problem B, a cosine function. So, amplitude. The amplitude is the number in front of the cosine, so it's just 1. Period. The period is 2 pi divided by the number in front of your variable. So 2 pi divided by 2, which is pi. Your vertical shift is the number being added or subtracted on the end. There isn't one. And your phase shift is the number being added or subtracted to the x. There isn't one. So that makes this one easy. This is just basically a cosine graph with a shifted period. So my period has changed. If I were to look at Desmos, let me find my Desmos. If I were to look at Desmos, you can see how the graph would change. So here is a sine, move that out of the way, a sine of x. And then let's compare that to a sine of 2x. So what you see here is that the period shifts. So think about a slinky where you expand the slinky and then you shrink the slinky back down. So the red one is our typical sine curve. Stop moving. The red one is our typical sine curve, and then the blue one, the period has doubled. So in the amount of time it takes for this point to occur on the red graph, which is our original one, we have one hill. Our blue one has already gone through one entire cycle. It's gone up and down in that same amount of time because we doubled the period. So that's the difference when you look at them. However, when you're graphing it, you don't have to necessarily show the difference between the two. You just need to rescale your period. So over here, remember, we put the period at 2 pi. On this one, we're just going to mark the end of our period at pi. So then this would be pi halves, pi fourths, and 3 pi fourths. And then our amplitude is 1 and -1. And then we're basically done. Remember that the cosine starts at the top of 1, comes down, valley, and then ends on a hill. Okay, next one. Both C and D have some variation in their periods. So C has an amplitude of 1/2 and a period of 2 pi divided by 1/4. Now, long version, 2 pi divided by 1/4 is 2 pi times the reciprocal, 4/1, so that's 8 pi. Okay, I'm going to erase this now. You can remember how to do that. Our period is 8 pi. There's no phase shift, no vertical shift on this one. Okay, so here goes. Period, 8 pi, half of that, 4 pi, half of that, 2 pi, half of the other one, 6 pi. And then all we need to do is mark our amplitude at 1/2 and -1/2. So now we graph. It's a sine function, so we start and come back down, go down, come back up. Okay? Now, as far as the 5 points go, again, let's do that on another one just to practice with our 5 points. So our 5 points would be here at 0, 0. Here at 2 pi, 1/2. Here at 4 pi, 0. Here at 6 pi, -1/2. And then our last point is here at 8 pi, 0. Okay? I'm just going to point out to you. Okay, back to this. So the only thing I wanted to point out about problem D is its amplitude is 3, but that's no big deal. Its period is a little bit different because the number in front of x is pi. So if you were calculating the period for part D, you'd go 2 pi divided by pi. That gives you 2. So this is the first one we've encountered where the period doesn't have a pi in it. So all these other periods had 2 pi, pi, 8 pi. So this one, when you draw it, you just come over here and it's just a plain old 2. It does not have a pi attached to it. Okay? All right, we're going to do just a couple more of these, move to the next page. Problem E is unique because it has a negative. So what does the negative do? Well, think about a parabola. If I gave you x squared, it opens up. If I gave you negative x squared, it opens down. Well, the sine curve is going to be the same thing. So if my original sine looks like that, then my negative sine is going to look like that. Okay, so it's just going to flip everything upside down. So here we go. Amplitude is still 1. Period is 2 pi divided by 4. So pi halves. And this has no vertical shift and no phase shift. We'll get into those next. Okay, so then how do we do this one? We write pi over 2. That makes halfway pi over 4, pi over 8, and then this would be 3 pi over 8. Amplitude is 1. Now, your regular sine I will graph as a dotted line. So if I set this graph up, I would graph the sine by going up, and then going down and coming back up. But that's not what this one looks like because it has a negative here. We are going to go down first and then back up the hill second. Okay, 2 more and then this video is done. G, this part right here is a vertical shift. So we'll go ahead and tackle that. And then problem H, this part right here represents a phase shift. So we're going to tackle one of each of those problems and then the video will be finished. So here's how it works. Vertical shift. Let's go through everything else. Amplitude, 1/2. Period, there is not a number in front of the x, so your period is just a natural 2 pi. And there's no phase shift, but this one has a vertical shift down 1. So here's what we're going to do. Draw a coordinate plane. Normally your sine is centered on your x-axis, but we're going to move it down 1. And I'm going to draw a dotted line to represent my new axis. Then my amplitude is 1/2. So if this is -1, then here's 1/2, and here's 1.5 or 3/2. So that represents the height of my sine curve or the amplitude, which is 1/2. Then I'm going to come over here and mark 2 pi, pi, pi halves, and 3 pi halves. Okay, that's all there is to it. We just shifted it, and now we graph it just like we would have otherwise. So it's a sine. It starts at, normally it would be at 0, 0, but this one's, remember, been shifted down 1. Draw the top, draw the bottom. Done. So this point right here, just to make sure you understand what's going on, that point is at pi halves, comma, -1/2. I should have put the negatives there. Okay, last problem for the video. Switch colors again. So this one, now we have a phase shift. Let's go through everything. Amplitude, 2. Period. There's not a number in front of the x, so it's just a regular 2 pi. There's no vertical shift on this one, but we have a phase shift of plus pi. So that means we're going to go to the right pi. Okay, amplitude 2, we didn't move vertically, so we don't have to worry about shifting our x-axis. Period is 2 pi, so I'm going to put that here, 2 pi, pi, mark those ones. And now I'm going to graph this as a dotted line, and then I'll come in and do my phase shift after that. So cosine starts up here, comes down to the first fourth of the way there, comes back up to 3/2, and then back up to the top of 2 pi. So now I'm going to switch colors and graph the phase shift. So every point that you see here is going to shift right pi. So this point here is now going to be above pi. This point here, let's go back, this point here is going to be over pi. So instead of this dotted section here, it's going to look like that. This point at the bottom of the valley goes over pi. Now, I do need to extend my axis a little bit. So here's 3 pi. So then this comes up and like that. Now we could go ahead and draw in the rest of this on the left side and it would look like that. But that is our cosine shifted pi.